Okay, so we are starting Unit 6 today, which is all focused on circles. It's not going to be just the simple version of circles like you did in 7th grade and stuff. This is a fairly tough unit, so please try not to get behind on things. I would try to have your homework done like day by day, not waiting for it to pile up, because then you might be a little overwhelmed with the information. Remember, I have tutoring virtually and in person, always on Mondays, typically on a little while for Tuesday and Thursday as well. So message me if you're wanting to do that virtually, because I'll make sure you have the link. All right, so first day is usually always pretty long because we have like some vocab and some intro information and then the day's lesson. So hopefully a lot of this vocab you're familiar with, but if not, we'll go over it, and then some of it will be a little bit new. So first thing, a circle is a round shape that has a total of 360 degrees. And since I've already filled these in, you may have to like pause and fill these out and then come back, listen for the explanation. So center is a point in the middle of a circle, and the circle is named using this letter. So like this drawing over here would be named, okay, well that would be circle A because its center is point A. All right, radius is a segment from the center of the circle to the outside edge, and it's halfway across the circle, okay? So for example, let's say this was 4 centimeters or something. All right, diameter is a segment that has endpoints on the outside edge of the circle, like this, and it does go through the center. It has to go through the center like this, and that is all the way across. So one thing you want to keep in mind and remember is the radius is half of diameter, and diameter is 2 times the radius. It's like in this picture, if the radius was 4, that would make the diameter equal 8. Okay, chord is a segment. It may have, occasionally may have lines going on, but it would only be looking at this portion, the segment, in which both endpoints, so typically those are going to be defined by letters, so it may say like A, B, or whatever. Those endpoints lie on the outside edge of the circle or on the circumference. One thing that some people remember for it is it's like a bad diameter because it doesn't go through the center like a diameter would, and that diameter wasn't perfect, but it would be just 2 endpoints on the edge, okay? So that's the main difference. Chord and diameter must go through the center. Okay, now these, chord may have been new for you. Tangent and secant will probably be new. A line or segment outside of the circle that touches the circle at exactly one point and never extends through the circle is a tangent. So like this example on the bottom here, this would be an example of the segment option, okay? So it touches here at this point. Let's say that's E maybe. And then this one would be an example of it. Technically that one is a ray, but it could also be a line. Maybe that's at point D. So that's the point where it hits the circle. All right, secant is a line that crosses the circle at 2 points. So see, it is a line, so it has the arrows on it, and it crosses the circle. So maybe this is like point E, and this is point F. So it's never going to be like this, okay? That wouldn't be, because it doesn't go through twice. So it's like cutting off a slice of it. Okay, so next you have arc. An arc is a portion of the outside or the circumference of a circle. The symbol is shown as AB, so like, or whatever letters it is. So like for this example, if this was A, this was B, that would be shown as arc AB. So we say this arc AB. All right, semicircle. So these 3 are all types of arcs, okay? Semicircle is an arc with endpoints on the diameter. So maybe this is circle C, and that's point D, point E. An arc has to go around the outside. So there's the diameter. This arc here would also make a semicircle because it goes from endpoint to endpoint of the diameter. And this is exactly 180 degrees. We're going to use that a lot in today's lesson and homework, is that semicircle part. All right, minor arc is an arc that is less than the semicircle of a given circle, or less than 180 degrees. So an example on this, maybe, this part here is the angle within the center. Sorry, got a phone call. So I was saying that, so on a minor arc, so these two segments, that makes the angle at the center, but the arc is actually this part here along the outside. So maybe that's, even if there's another point on this line, so maybe there's B and there's C, okay, well that would just be called, it's represented with two letters, okay, so that would be called arc AC. AC. It's really important that you remember the two-letter portion, okay? That'll come into play a lot. All right, major arc is going to be more than 180 degrees. So maybe I have, remember there may be multiple points in between here. All right, so for this one, this arc is all the way around here. I want to say that this one that we don't have here, the minor arc, is like 108 degrees, okay? So the major has to be more than 180. Well, this big part here, it's going to have to be over 180 because it's a pretty big portion of the circle. And you use three letters to name it. So I could technically say arc ACD. I just picked B to name mine. You can use either one, but the endpoints have to be the endpoints. Like it has to start with A, it has to end with D, which I did, and then you could have picked B or C. All right, now the two angles that we're focusing on today are central angles and inscribed angles. Main part you're looking at is the vertex, which means like if this is an angle, this point here, so B, let's say, that would be the vertex. Okay, so that is what you're really focusing on and looking at. An angle whose vertex is at the center. So if I have my center of the circle, I'm going to name this one X. All right. Then a central angle may look like this, let's say. So it has its sides, it says, are radii because it goes from the center to the edge. So we'll make that Y and Z. All right. So it's a central angle because its vertex X is at the center. All right, inscribed is an angle whose vertex is on the edge of the circle and whose sides are inside of the circle. So like this. So here's the vertex and it's sitting on the circle, whereas the central was in the middle there. So maybe that's A, B, C. All right, so now you're going to take a minute and using your vocab that we just went over, you want to try to fill these out, okay? You're matching each of them. I'll do one with you and then I'll give you a little edit. So, for example, like LQ is right here. And I would look back in your notes, like look at all your pictures that we drew and see which one that looks like. In this case, this one would be the tangent because it is a segment and it only touches that circle once. I will make one quick edit to this. One of these is listed as a segment, should technically be a line. I think it was UY, yeah. So UY should have actually had arrows on it. Okay, so that makes that one a line. So take a minute, pause the video, because when you start it, it will have the answers, and see if you can match those up. This will be like the first question when we get to a quiz. This will be a question you have, so make sure you have a good understanding of it. Okay, so like I said, this will be the first question when you get to the quiz for this unit. We'll use these words a lot. I will probably put a Quizlet on Canvas as well if you think you need to like do some extra review on the words, okay? So flip the page. All right, here is the actual like math solving. I told you first day's long, you know this. All right, so arc measures. We are going to base this on central angles and inscribed angles. All of this is like what we're looking at. So arc, if they ask for the arc measure, okay, that is the angle. Oops. An arc creates at the center of a circle, okay? So it may say like the measure of arc BC. That means it wants the answer in degrees, okay? Okay, and this is the part you for sure have to get down today, so pay close attention. Central angles and arc measures. Central angles should be super easy. You should not miss them. So a central angle is equal to its arc. So if I'm looking here, they give me angle ABC. Is that a central angle or an inscribed angle? Central. So what is the angle? 110. So the actual formula for this is angle equals arc. Well, then I just kind of plug in. If the angle's 110, I replace the angle with 110. And they're wanting the arc, which is this. So those two lines that extend out from the angle, where they hit the circle is the arc that it forms. So AC. So if the arc equals the angle, what's the arc equal? 110 also. Okay? So I would say arc AC equals 110 degrees. So if you have the central angle, it's the same as the arc. Arc angle equals arc, or arc equals angle. Same thing. All right. Arc addition postulate. This just means, it's kind of like we did segment addition postulate, angle addition, all that. So if you have two adjacent, what's adjacent mean? You remember that? Mm-hmm.
Right next to?
Yeah, next to or beside, okay? So if I have two adjacent arcs, then how would I find like what the two together make up? What would I do with them? Add them, yeah, so it's the sum, so think add, of the measures of the two arcs, okay? So for example, let's say, write this above the line. So arc AD and arc DC. All right, it's run. Okay, what's the degrees for arc AD? 32, because it's the same as its central angle since it is a central. If it were inscribed, it would not be, but we're not to that. So 32 plus, what does DC equal? 90. And what would that up to? 22. So then, look here, what angle or what arc do those two form together? AC. It's still a minor, right? It's not more than 180, so I don't call it ADC. I just say, so AC is 122.
Is that how it's going to be on the test, like how we fill it in? Or do we actually have to write out the entire
No, you'll just do like the equation or whatever. You'll see some in a minute. Okay, inscribed are slightly harder, but once you remember the formula, it should not be too much. So an inscribed angle is half of its arc, or the arc is 2 times the inscribed angle. Okay, so let's look at this first one, so right here. Okay, they want AC. Okay, so look here. 84, is that the angle or the arc? The angle, because this is where the two straight lines meet, right? The degrees don't necessarily tell us that because we measure arcs in degrees too, because circle you can't really measure like a straight line, right? So this is the angle. AC is the arc. So you got to think about which you have. I just kind of think, which of those looks like it's going to be smaller, the angle or the arc? The angle. Okay, that's how I sort of remember it. So read your thing. If you have the arc is 2 times the what? It's 2 times the angle. So if you have 84 for the angle, what would I do to get the arc? Yes. So 84 times 2 is what?
168.
Okay. All right. Now if I was going the other way, so you'll look at, let's look at the other triangle. So this one. So ABC, it did say angle. So it wants the angle, okay? What is 68? How do we know 68 is the arc? It's on the outside like that. It's going around the circumference. So here, what would I do differently since I have the arc and I need the angle? Divide it by 2 or take half of it. So what's half of 68? Yes. All right, I do want you to write, if you're given ones like this with just a regular number, it's easiest to just have that understanding that the angle is smaller. I multiply it by 2. The arc is bigger. Divide it by 2 to get the angle. Once we get into like x and different expressions, the actual formula is angle equals 1/2 arc. All right, which I did put on the back page of your notes, but if it's not very complex though like that, it's just a number, then it's easiest to just quickly multiply or divide. Okay, I want you to take like, I don't know, a minute. 1 through 10, I think I'm taking off, I forget which ones, so let me look real quick. I was going to take off 2 of them maybe. Actually, no, we'll do them quick. So 1 through 10, I want you to label, go through and just write the angle type, okay? So your options are either, what 2 are we talking about? Central or, what's the other? Inscribed. So on 1 through 10, they don't all have an angle type, but any of them that say angle type, write which one it is, okay? And then we'll come back and check them. Okay, so you should have, for number 1, remember you're looking at where the vertex is. So like, N is where those angles, those 2 straight lines meet, where they cross at. So that was central. Now 2, some people got confused because they do give you the center is D, right? But that's not where the lines meet at. Where do they meet at? B, which is on the circle, so that's inscribed. Okay, so let's actually try solving now. So a few things you can use for solving. You can use, if you have a semicircle, like if you have enough parts that add up to the semicircle, you can use your total of 180. If you have the entire circle, you can use 360. You can use vertical angles. Those are throwing it back, but they're ones that are across from each other and they're congruent. Or we can use our new formulas like angle equals arc, angle equals 1/2 arc, okay? So let's look at this one. We're trying to find x and arc LK. So I'm just going to highlight that real quick. LK is here. Now, how do I know that I don't go the other way? Like, why would I not go here to here? That would be a major, correct. So since it's minor, I know I want to go the shorter distance between the 2. All right, so if that's LK, I need to find x before I can. All right, so I want to look at, do I have anything like over here in the circle? Did they give me any information for that? No, but I do have like essentially all of this side, right? Yeah. So what does that form? if it's half of the circle?
Then
Semicircle, which is how many degrees? 180. So all I'm going to do is I'm going to combine those two expressions, like this, and set them equal to 180. The parentheses really don't matter here because I'm just adding the two. So you can skip this step here in a minute. I'm just showing you what I'm doing. So if I add both of them, I write it like this. But what I'm saying is you can combine them and skip this step. So like, what am I going to combine in this? What goes with 5x?
17.
Okay, so now I have,
22.
yes, and I combine 23 and negative 41, which will give me what? Negative 18. Total stays the same. Okay, hopefully this part we don't need a whole lot of help on. So instead of minus 18, I'm adding it, right? So now I have 22x equals 198. Divide by 22. What does x equal then? And for some reason, these equations a lot of times have very big coefficients and stuff, so do make sure you're 9, did we say? Okay. So that's part of the question, right? Find x. We found x. What do I do to find LK? Arc LK. Caden?
You plug it in.
Plug it in. So LK is 17x minus 41. So after 17, I'm going to put parentheses 9 because that's 17x means 17 times minus 41. Type this whole thing in your calculator. Like you don't need to do, you just type it as one expression. And I know it should be less than what number? What does it have to be less than?
180.
180 because it's less than half.
149.
You guys agree with 149? Okay, and it is an arc, so I can still label it as degrees. Arcs and angles get degrees. Okay, well, any questions on that first one? All right, let's try an inscribed. This one should not take long at all. So technically the formula is angle equals 1/2 arc. But it's going to be quicker on this one. Am I given the smaller part or the bigger part? Smaller because the angle is smaller than the arc. So what do I do with the angle to get the arc then?
Multiply by 2.
Multiply it by 2.
94.
Then you have to look.
So which one? I'm looking for BC, is that right?
Yeah.
Okay, so I'm going to say arc AC was what? What'd you guys say? 94. Okay, why is that not my answer? It's not BC. So look at where BC is right here.
Subtract 180.
Subtract from 180 because this arc plus BC equals 180. So what is arc BC?
86.
Half of the circle, 180.
What was your question, Caden?
Add the little part so we can see.
What was the question? Okay. So I actually want you guys to start with 7. I know this is out of order. I'm going to change it next time. But so just do 7 on your own real quick. Should be a quick one.
Do 7 bars of
Yep, just do 7 real quick. All right, so 7, hopefully you saw, was an inscribed angle. Okay, because X was on the circle. All right, did we have, they were looking for WXY, right? So they want this. So they want the angle. What did we have? What was the 62? The arc, because it's on the outside. So if you have the arc, how do you get the angle? Have it. So 62 divided by 2 would give you the angle WXY equals 31 degrees. Okay, so once you can quickly recognize those and know, do I times by 2, do I have it? Those ones should be pretty quick. Okay. All right, so I'm going to pop up back to the top here. So number 3, central or inscribed? Central, because those angles stem from that point Z is their vertex, so that's central. All right, you may have to think for a minute on this one.
Why is this wrong? This is what I did at first,
Okay.
but it's wrong. I added all of them up. Is that wrong? And then
Did you, no it's not. So adding them all up is the right start.
okay.
Did you include
Nope.
this?
No, I didn't.
No, what is that?
90.
Right. And that is honestly the main mistake I see on this is people forget to do like, oh, plus 90. So we can add all of them up. So I can add all the x's. What is that? 8 plus 21, 39x. And then negative 12, positive 9, and 90.
87.
Okay. What is their total? If you added 360, right. So that's what I was telling you. You can use the total circle. You can use half the circle. Okay, subtract 87.
273.
273?
Yeah.
Okay. And divide by 39. 7?
Yeah.
So we got x. Okay, next thing they want is arc WX. Take a quick glance up here just to make sure. Am I going to go this way? So do I want that blue section? Or am I going to go this way?
Blue.
Blue. Because why do I not do the green section?
There's a minor.
It's a minor arc since it only has 2 letters. So that is important, like which way you look for it, okay? So WX, did they give us an expression for that one that we can plug into? Yeah, so we can plug into the 21. So I'm going to say 21 parentheses for times 7 minus 12. Do make sure you type the minus 12. Sometimes people leave that off. So arc WX equals
140.
135.
135.
I think it was 135. Okay.
Sound good?
All right, now the other one, a little bit different. So first of all, what's different about the arc VXW?
It's arc.
So, yes,
It's a major.
it's a major. This one is kind of tricky. Like, why do I not want to go, was it VX? Why do I want to go that way? So if I go VXW, why would I not do that? It's
It's more than.
more than, yeah. So which way should I go? Yeah, like left here. So V, then X, then end at W. So remember the end point should be like where you start, where you end when making that arc. There's 2 ways to do this one. So essentially I am looking for the distance all the way around that part of the circle. 2 ways to do it. Any ideas? Christian?
Divide 8.
Don't divide. Plug x in for that. So 8x plug in 7. What would that give us? So essentially 8 times 7.
56.
Okay, so that's now 56. All right, and then what could we do with the 56? Is that part included? No. So you could do 360 minus 56. That is the easiest way to do that one. But what is the other? Most people actually thought of the other way first. You can add up all of the others. So we would like, what I think we got, 135 for this one. You'd have to plug into this one and then add them all up, okay? So that one would take a little longer probably, but you could do it both ways. Right? Yeah. All right, number 4 is 4. So what's the vertex point for 4 of the angle? What point's at the angle's vertex? B. All right, so Caitlin, is that central or inscribed? Inscribed, good. Okay, now you're going to have to use You're going to get to where you have to start using the actual formula because if you see they have an X in here. So I can't just do like half of 40 is 20, okay? Like, not to that. So this one, here is the angle, right, that they gave us. Typically, we would say, all right, angle equals 1/2 arc. Do they give us the arc, though? No. We need that before we can do the formula. So any ideas how we can find arc AC?
92 probably.
You are going to use the 92, but it's not 92.
You add 162.
Okay, so add 92 and 162. What's that?
Subtraction from
254.
Then what do I do with that? So 254 is this arc and this one. Subtract from 360. Which is what?
106.
Okay. So that is telling me the arc here. I had to do that first. Now I can use the formula. Okay. Formula for inscribed is angle equals what? Close. That's central. 1/2 arc. There you go, Mariana. All right, now we just plug in. Did they give us the angle? Or an expression for the angle? Yes. What is it?
7x minus 10.
Good. Equals 1/2. Do we now have the arc? Yes. And you always, when you plug this in, you want to put this in parentheses because if it had been an expression, I need to distribute 1/2 to both. In this case, it's not. It's just 106. But sometimes, like, the x will be on that side. All right, what would I do first to solve this? The parentheses. 1/2 of 106 because this is times. So what is that? Half of 100 and half of 6. What? Yes. 53. Add 10. 7x equals 63. Divide by 7. X equals 9. Are we done? How do we know? Yep. So always check back and make sure because sometimes you guys forget to do the other part. Oh, sorry. Do we need a sec there? All right. Riley, what type of angle is 5? Inscribed, because D is the vertex point there. Okay. Here they want two things. They want angle ADC, and then they want arc. They want this. Arc AD. All right, so we're going to have to do a couple things. We can start with either of these, really. Caden? Okay. So if that's, I need my formula. Angle equals 1/2 arc. Do I have the angle? Where's the angle at? Where's the point? D. Is there anything here to show me that angle? Okay, so make that X then. If you don't have it, that's your X. So instead of angle, I'm going to write X. 1/2. Do I have the arc? Okay, so remember the arc is where that angle meets the circle. So what is the arc of this angle?
36,
No, like what 2 points? Sorry.
39.
AC.
AC. So I add them, yes. So 39 plus 61. You can either do it like this or just like add them in. And what is that? What's 39 plus 61? So I'm just going to change that to 100. So what's X going to be? 50. So the angle, and that's actually the angle too. We just made it be X, okay? So there's nothing to plug in. We made X the angle. Okay, now AD should be fairly simple. There's not a lot of, no X involved. So you have all of the circle except AD, right? It's the only thing missing. So how can I find it? Yes, so I do 360 minus all of these. So if you want to add them up first and then subtract, or if you want to do like 360 and then just minus, minus, minus,
Isn't it minus 150?
either way.
I didn't see the 147.
No. Okay. Yeah. Well, that was 100 though.
13.
All right. What did you guys get? Me too. And I did minus 247. So arc AD equals 113. Okay. Number 6 is what kind of angle? Inscribed, because the vertex is at point D. Okay, I want you to try this one because I want you to see if you can set up the equation. Quick thing I want to note, if you flip your notes to the very back page, this is the whole unit, so don't get too overwhelmed yet, but central angles and inscribed are right here in the middle, and it gives you those formulas. So if you need a quick reference throughout the unit, that's going to be a good place to look, okay? So it gives you both of the formulas there when you need those. So let's do 2 minutes, try to solve X.
No.
Just number 6, sorry. And if you're totally lost, please let me know.
Is this right so far?
Hold on.
You probably won't help me
She asked me what I go with you. Really? Say no more.
Oh. It does with the angle. Oh, no, does it? No,
This is right?
Do you though?
Do you
Sometimes.
She just said it.
No,
That's the equation.
What did I do wrong?
you're finding X.
And X is
No.
79, buddy. I was giving you 79.
Dude, 79.
No, X is not 79. Yeah.
Yeah.
Right, right. Here, make it easier. Half 158. Half.
Okay, so let's check in here. The formula is angle equals 1/2 arc. If it helps you, maybe label on your picture. So is 158 an arc or an angle? Arc. So that means I'm going to plug it in after arc. So instead of arc, I'm writing 158.
So that means 8 and
What is the angle here?
solve.
Do they give you the angle?
Simple math and solve.
Yeah.
Yes.
Mine's not.
Yes. So sometimes that's going to be a regular number. Sometimes it's going to be an expression like that. All right. I would distribute 1/2
Do we have
first.
to do that step right there? Or can we just right away half it and just do the equation?
11.
I would probably take either. So what's half of 158? 79. Good. Now add 9.
88.
8x equals 88, so that's going to be a nice even whole number, 11.
Multiply this by 2.
Is it okay if it comes out of the decimal?
No.
Don't everyone?
Wait, ever?
Ever?
Ooh, I don't know. I don't think I put any that were decimals.
Like number 8? Let's go.
I don't think so. Let's look at 8 then. We already did 7. Okay, so 8. Essential or inscribed? Inscribed. Preston. Okay, so my formula is what? Angle equals
Half times arc.
half times arc. Oh, something I forgot to tell you on this unit. Sorry. No proofs or anything. Actually, I don't even think there's any word. There's really not even like word problems on this. There's like 2 that have like a sentence, but you just like put it in a proportion. There is an equations test, but sometimes that scares people. Last year, almost every student got 100. So like that will be 20% of your test. It should really help you. Okay? Like, which helps because this test is hard. So that extra 20%, if you can just get 100 on the equations, that's a big, that's a difference in a D and a C, or a D and a B. Okay? All right, so quick note on that. So like, you have a test over the equations. Listen up. You'll have a test on it, but then after that on the test, you get the equations. So it's kind of different than our usual. All right, sorry for the side note. So plug in, what is the angle here? What's the angle? 67 equals, did they give us the arc of that angle? So where it should be LN.
That's why.
Yes, so parentheses, this is where I said it's really important for the parentheses. 4x plus 58. Okay, what do those parentheses tell us to do with the 1/2? Multiply by both. Don't forget both.
So it would be 2x.
2x. And then, if you remember drawing like the rainbow things, then half of 58, which would be what? 29. No, because you can't type x. You know what I mean? Okay, 67 minus 29 would be equals 2x. Divide by 2, what is x? 19. Okay, I will show you one thing on 9, and then I'm going to have you try because it's really just like a puzzle, and it depends which order you do it in. Only thing that we haven't talked about yet today is vertical angles. You will see those occasionally still. So like, I'll give you the hint. Well, vertical angles are where they cross, like they make an X. So if RS is 25, what is its vertical would be QU, making QU what? 25 also. Verticals are congruent. Okay, so after you have that, remember you can use 180, 360. So I want you to try to find all 5 of those. You have 1 minute. You don't even have to show work. You should just be typing in your calculator.
Oh, I think so.
What a guy.
No, it's not, but it's not half. It's like a little more. It's a little more.
Dude, it's literally all we did was, all it is the stuff. Smashing definitions stuff.
So quick hint, TQ. You should be doing what? No.
Yeah, it's
TQ
You add the.
is 44 and the 25 together.
I mean, QR is.
QR, once I show you this one, you should hopefully be able to do the rest. QR, I don't really have any way to know except using a semicircle. So you can do 180 minus 25.
Is there a decimal in here?
No, no decimals.
I did.
Well, I got a decimal.
180 minus what you said?
180 minus 25, right? You get this.
It's not as bad as I think. It's not right.
No, I got 155. For that. I know, I'm just saying,
Where's
this
the word
is the side I got, right? Like, I got the, this thing, I got this.
Okay, well, I know the word.
That is 155, right?
This one is.
J,
And then-
Major
Nope.
word.
No, I'm talking about the.
Yeah, 'cause it has three.
Yeah, that's
So
cute.
I did this one.
And then, oh wait, H might be.
Oh, you got it.
All right, so Q,
No, I'm still watching.
arc QR. I would do 180 minus 25 because it makes up that green section, okay? So 155, do we get that?
But it's not equal, yeah.
55. All right, TS.
This one.
Oh, let me write these in as you go. That way you know that you have them. All right, only way to find TS. No, sorry, there's two ways. How can we find TS? Ryan, do you know how? Charles?
180
Okay.
minus 44 minus 25.
Did you get 111?
Yeah.
Okay.
That's how you do it, though.
Okay, SQR. What is different about these last two arcs from the top ones? There's three, so they're major arcs, meaning it matters which direction we go to find. So SQR, I go here to Q, down to R. So that is almost all of the circle. What is not included? So what's the easiest way to solve that?
360 minus.
Yes. Which will give you what?
You're gonna wanna use that.
335.
Okay. And then RQT, let me do this one in a different. So from R, should I go up or down on the circle? Here, let's look. If we went down, we're going, was it RQT? I would go here and then all the way back around to T. I do not want to go like more than the circle, okay? Because I have to start with R, end with T. So I start
Straight up to Q.
up to Q, then to T. So they go in order, okay? So I want to add all of the arcs that are along that. So the first one's 155. Okay, what's the next one?
180. It's 180 because it's 25. So, right?
Oh, you're adding that. Yeah, I'm saying all three that make it up. So yeah, so that's 180. And then also the 44. Okay, so what does that give you total there?
224. Right? Yeah.
You guys agree?
Yeah.
And I know it should be more than 180 because it's a major. Are both of these more than 180? But also less than what?
360.
Yes. So kind of do a check on that at the end. All right, last one. This one is much easier than it looks. And we're going to finish just in time for lunch. Okay, circle E. That's just the name of what they're naming it. Okay, ABD. That is here. Okay, is 6x plus 26. So difference here is you have to label them. Okay, ACD is then, here, let's do that in a different. That's here. We're labeling it 6x plus 26. Okay, we're looking for the arc. All right. Currently, so we usually do angle equals 1/2 arc, but do we have the arc?
Well, you wrote the same thing twice.
I did, you're right.
Oh, we didn't do that right?
Sorry. My bad. 13x minus 9. So look at where they open. Remember, where the angle touches the circle makes its arc. So like, what's the arc for this angle? The ACD. What's its arc going to be? So follow the blue lines. Where do they hit on the circle?
Yeah, they
The edge.
Mm-mm.
100.
Here, they end at A. What's the other endpoint
C,
of this line?
D,
D. Okay, so its arc is AD. Right? Now angle ABD, what is its arc? This side ends at A. Where's the other side end at? D. So what do you notice then about their arcs?
Like, make 360 together.
No, they're the same. So those angles have the same arc. If their arc is the same, what else is going to be the same? Their angle. So how could I write the equation then?
equal.
They equal each other. Okay, we're going to do this one real quick before lunch, so just go quick. All right, I would minus 6, 7x, add 9 is
26 is, geez. Oh my goodness,
35.
30 to 35.
Divide by 7, x would equal 5. Okay, only tricky part here. Well, maybe the second tricky part. They want the arc. So what can I do to get the arc? What can I do first? Plug into the angle. Does it matter which one? No, because they're equal. So let's do, I don't know, either one. You can do this one or the other one. Just do one of them.
56.
Okay. So if the angle is 56, what do we do to get the arc?
Times by 2.
Multiply by 2. So arc AD equals 112. Yeah. Okay, please remember, so I'll give you your homework. Please do not get behind on homework this unit.